the values of P and Q. Okay, so that's what we know. Sorry, I should have written that out before. I forgot. And we're going to work on the new values that we've learned, so all those new identities that we've just learned to answer this question. Now, the thing I'd ask you to bear in mind with quartics is that the identities themselves are more cumbersome, so try as much as you can to always be looking for what's going to be the easiest for you to work out. Before we do anything else, I just want you to remember that if gamma is minus 2 plus 4i, oops, and delta is the conjugate, then delta must be minus 2 minus 4i. Okay, so don't forget the easy parts at the beginning. Right, so what does it ask us? So this one has got an add-in. So I am going to guess that we're going to be using alpha plus beta plus gamma plus delta. And we know that alpha plus beta plus gamma plus delta equals minus b over a. So alpha plus beta, I don't know what they are. I do know what gamma is. It's minus 2 plus 4i. I do know what delta is. It's minus 2 minus 4i. And it's equal to minus b over a, so ab, negative 2 over 1. So I can substitute all of those in and work out what I've got. So as always with conjugates, those two parts are going to disappear. I'm left with alpha plus beta minus 4. And then if I add 2, it gives me minus 2 equals 0, which is exactly what I want in the question. So by using that identity, substituting in the 2 that I know, I get to the thing that I want. That's quite neat. And then for this one, alpha beta plus 3. Now if I just remind you of the identities that we know, this is going to be really horrid. This is going to be really horrid. I might end up having to use one of those, but actually this one here is going to be my preference to start with, just because there's so many fewer things going on. So I'm going to try this one. If it doesn't work out, I'm going to have to go back to using one of those. So I know that alpha, beta, gamma, delta is E over A. A, B, C, D. Actually, I'm going to put it in for now. E over A. Right, alpha I don't know. Beta I don't know. Gamma I do know. Delta I do know. And that's equal to E, A, B, C, D, E. So 60 or minus 60 over 1. Okay, alpha, beta. If I multiply these out, I've got 4 minus 16i squared minus 8i plus 8i. So those two are going to cancel out like they always do. I squared is minus 1 times by minus 16 is plus 16. So 4 plus 16. So I'm left with alpha beta times by 20. If I divide both of them by 20, alpha beta equals negative 3. And then if I bring that over, alpha beta plus 3 equals 0, which is what I wanted up there. So that's quite tidy as well. Okay, hence find all the roots of the quartic and the values of P and Q. So I know what gamma is, I know what delta is. I don't know what alpha and beta are, but alpha and beta are my two unknowns. I have two equations with those two unknowns in, so I am able to solve them simultaneously. Oh, that's nice. So I know that alpha plus beta minus 2 is 0. I know that alpha beta plus 3 is 0. If I rearrange this one, I don't know, let's rearrange it for alpha. So alpha is 2 minus beta. I can substitute that into here, which then gives me alpha, which is 2 minus beta, times by beta, plus 3 equals 0. Which, am I still on the page? Which is 2 beta minus beta squared plus 3 equals 0. So beta squared minus 2 beta minus 3 equals 0. So beta minus 3, beta plus 1. So beta is 3, or beta is negative 1. And if I substitute those back in there, I reckon I'll just squash it in. So if beta is 3, alpha is 2 minus beta, which is negative 1. If beta is negative 1, alpha is 2 minus negative 1, which is 3, which is what we would expect because actually they're the same roots. So that gives us all 4 roots. One of them is 3, one of them is negative 1. Doesn't matter which way around they are. The other one, or the other 2, are gamma and delta, which were given to us in the question. So what did it say? Hence find all the roots. So the roots are the roots are 3, negative 1, minus 2 plus 4i, and minus 2 minus 4i. So that's all the roots. And then the last part of the question says find the values of P and Q. So I'll have to do some paper shuffling, I'm afraid. Okay, so you can't see that. So what's happened? Why is that not working? It's gone all out of focus. How strange. Sorry about that. So we knew that the roots were, let's say, alpha is 3 and beta is negative 1, although it doesn't really matter which way round we put them. And then we had gamma equals negative 2 plus 4i, and delta equals negative 2 minus 4i. It wouldn't matter if you had those the other way round, we'd get the same answers in the end. It wants us to find the values of P and Q. So if we think back to our identities, that's A, B, C, D, and E. So if we want P and Q, we want identities that involve C and D. So we know that the sum of the alpha betas is C over A. So I'm going to use that one to find P. And I know that that's the same as alpha beta plus beta gamma plus gamma alpha plus gamma delta plus beta delta. It's C over A, which is P, over A, which is 1. So I know that all of these are going to be P. Alpha is 3, beta is minus 1. Beta is minus 1, gamma is minus 2 plus 4i. Gamma is minus 2 plus 4i. Alpha is 3. Gamma is minus 2 plus 4i. Delta is minus 2 minus 4i. And beta is negative 1. And delta is minus 2 minus 4i. We know that that's equal to P, so it's just a case of multiplying that out. So negative 3 plus 2 minus 4i. Let's see, minus 6 plus 12i. Hang on, something's gone wrong here. Beta, alpha beta gamma delta. Where's alpha delta? 1, 2. Oh, I've missed one out. Okay, so I'm going to stick it on the end. Plus alpha delta. Stick it on the end here, sorry. Plus alpha, which is 3 delta, which is minus 2 minus 4i equals p. Sorry about that. Should be 6 of those, I only put in 4. So hang on, I got to here. Plus 4 minus 16i squared minus 8i plus 8i plus 2 plus 4i minus 6 minus 12i equals p. So let's look at the i's. Minus 12i and plus 12i, okay, that goes and that goes. Got 4i and minus 4i, and I'm left with 16i squared, which is positive 16. So then it's just a case of adding up the numbers. So you've got negative 3 plus 2 minus 6 plus 4 plus 16 plus 2 minus 6 equals p. So what does p equal? Nine. So p is 9. And then we're going to do exactly the same for q, except q is the term involving d. So I still know that alpha is 3, beta is minus 1, gamma is minus 2 plus 4i, delta is minus 2 minus 4i, and for q, which is the term involving d, I know I'm looking at the sum of the alpha, beta, gammas. And if I wrote all of those out, trying not to forget one this time, I would have alpha, beta, gamma plus alpha, beta, delta plus alpha, gamma, delta plus beta, gamma, delta equals minus d over a. And then all we do is exactly the same as we did for the last question. So alpha 3, beta minus 1, gamma minus 2 plus 4i. Plus alpha 3, beta minus 1, delta minus 2 minus 4i, plus alpha, gamma, alpha, gamma, delta, plus beta, gamma, beta, gamma, delta, and that's equal to minus d, so minus q over a, which is 1, minus q. And then you want to multiply all of those out in exactly the same way. All the imaginary numbers will cancel out, and you will be left with q equals negative 52. Okay, there you go. Right, I'm going to, on the next sheet, well, it's included as an attachment actually. It's exercise 4C.